So today we have Scott from Red Hat with us to talk about Quarkus, and I will turn it over to you, Scott, to talk about your history with Red Hat and this great new technology.
Great, thanks, Melinda. It's always great to, collaborate with Moser on, and this is a great forum, by the way, to get information out. So welcome everyone. Happy you could set aside some time to join us today to talk about a really cool technology called Quarkus. So as Melinda said, my name is Scott Sigmund. I'm a solutions architect with Red Hat. I've been at Red Hat about, well, a little over 5 years now. I have a long history with Java, like many of you, I'm certain. I worked at Sun Microsystems for many years in the Java software group. And, that's where I fell in love with Java. I hope today that you'll see and hopefully understand why we're excited about Quarkus. It certainly reinvigorated my love of Java and the framework in general. And I think you'll see today that this is a really interesting technology that will hopefully, if for whatever reason you've kind of waned on Java, might bring your interest back. So it's got a lot of momentum both internally here at Red Hat and obviously externally too. We've got a lot of interesting projects that are on the horizon and we're working on now. So let's dig in and talk a little bit more about what Quarkus is and maybe the benefits that you can realize from Quarkus. So I'm going to quickly kick things off and talk a little bit about Red Hat and Java for those of you that don't, or maybe don't understand how we've contributed over the years to the to Java in general and OpenJDK here in recent years, most certainly. So what you might not know is actually Red Hat is now leading the OpenJDK 8 and 11 projects. So that was handed over to us from Oracle, and so we're continuing to drive community innovation with Java on both OpenJDK 8 and 11, and I anticipate that moving forward, we will continue to be the stewards of OpenJDK. Rest assured, as an open source company, that we're going to make certain that we continue to address those features and performance and functionality that you're all looking for with Java applications. So we'll continue to release versions on a quarterly cadence. I'm sorry, well, on a regular cadence. I'll talk about that cadence here in a little bit. And we're also obviously involved in a lot of upstream projects and have been for a long time. In fact, we're part of the OpenJDK vulnerability group and the governing board for OpenJDK. We've done a lot of work, and you'll see how that's reflected here with Quarkus as we go along here. But we've done a lot of work on tuning Java to run in Kubernetes environments, specifically our OpenShift framework container platform. And as I mentioned, we've done a lot of and worked on a lot of different projects. We've led the 64-bit ARM port of OpenJDK. We've developed a really unique garbage collector called Shenandoah. And you're probably familiar with some of these other projects here listed on the screen: ActiveMQ, Eclipse Camel, Drools. All of those are technologies that we've either been the lead on or we've collaborated with the community on. And of course, we established the Quarkus project, which is what we'll talk about today. So just some background, just so you understand our involvement with Java. It goes back 15 years. But in case you were wondering, we're very much involved in the community, and that's kind of what led to the evolution of Quarkus. So why Quarkus? Well, like many of us, we're looking for a stack to write Java apps that can address cloud native requirements, right? Being able to run in hybrid cloud platforms in Kubernetes or in like OpenShift, as I mentioned a little bit earlier. Certainly you want to be able to support those applications that you've written, maybe in Spring already, like any 12-factor applications, for example. Certainly we want to be able to have flexibility in deployment and the reactivity of the deployment, and even the scalability for that matter. Certainly, I'm certain, most of you are at least exploring microservices or probably have some deployed today. So we need a stack that can support that density and be able to support the communication patterns of those applications that you're writing. And of course, serverless is coming to the forefront, and startup time is something that's crucial in a serverless environment. And of course, traditionally, Java really didn't fit in that space of fast startup times that could support a framework like serverless. But that's all changing with Quarkus. So this is just a continuum from monolith to functions, that journey that a lot of organizations have kind of embarked on in their environments. But the scalability, of course, is different, right? So you're going from bigger processes, the monolith, bigger processes, to a framework that can accommodate more instances. Right? So to be able to support that functionality of functions, being able to scale down to zero, right? Spending less time on services, starting up services quickly, scaling them back down. So all this kind of plays into why we introduced the technology called Quarkus to address all those things we just talked about: cloud native, microservices, serverless, helping you move from this monolith to more of a serverless or function-based architecture. So what is Quarkus? It's actually a play on a couple of different words. Quark, which is of course an elementary particle, and then us, right? The hardest thing in computer science. Let's face it, as developers, sometimes we can be a little needy, and we're looking for specific ways to address challenges that we have in writing applications. So that's kind of the play on the word Quarkus. And what we'll be talking about today, and actually I'll be demonstrating, I'll be spending a lot of time walking through some demonstrations, but we're going to focus on 4 primary benefits of Quarkus. Number 1, developer joy. I'll talk about what that means here in a moment. Our tagline for Quarkus is Supersonic, Subatomic, Java. So we'll talk about size, going back to serverless, speed, the things that are required for those types of environments, fast startup times. We'll talk about how we can actually combine technologies that typically you had to make a choice between, specifically imperative programming and reactive models. And then we'll talk about the frameworks that are supported by Quarkus. And I think you'll find that it's pretty vast and addresses most of your development needs. So let's get into the first benefit, which is developer joy, and then we'll get into some demonstrations. So Quarkus is not just about being great for writing web applications or microservices, right? We're focused on more than just the feature set. We want to make certain that every feature works well, is simple, and has little or no configuration. And doing this in in the most intuitive way possible. So what we're trying to strive for is that we should make it trivial for developers to create simple apps and then easy to develop more complex apps. So we do that in a couple different ways. One of them is live coding, and I'll demonstrate this out of the box. There's no special requirement setup that's required. It works with your Java files, your application configuration files you'll see here in a moment, any kind of static resources. Essentially, when you run and you'll see this in a moment, we'll walk through the demonstration, but when you run a Maven compiled Quarkus dev, it launches Quarkus in development mode. And what happens is that when it receives an HTTP request, it will hold the request and scan to see if there's any kind of application source files that have changed, you know, the Java files, your config files, etc. And if they have changed, it'll actually behind the scenes transparently compile those change files and redeploy the application with the changes. And then that HTTP request will continue and you'll see the redeployed application. So what this helps us do is redeploy applications much faster than you would with a traditional app environment or app server. So all but, you know, these super large applications should take well under a second to redeploy, and we'll demonstrate that as we go along. Configuration files is another huge advantage of Quarkus. So gone are the days of 1,000 configuration files in different formats. We're looking for cohesion, and we've done that with a single configuration file. So that's all it takes for your Quarkus applications to configure every single extension, attribute, you name it. Anything that's required for your applications, logins to databases, for example. All of that is maintained in one configuration file. So that's the only configuration file that you need to work with. And there are hundreds and hundreds of different options that you can include in your configuration files, including those configurations for when you're in a dev environment or your test environment or a production environment, and I'll demonstrate that also. Quarkus is streamlined for 80% of the use cases that you're used to writing your applications against. And then we've got some flexibility with other frameworks for the other 20% of the use cases that you might have. So right out of the box, Quarkus supports a lot of the frameworks that you know and are working with today. And you'll see here also that we can also create native executables. So we have a notion of running Quarkus applications in a normal JVM environment, right, in a hotspot environment, or we can actually compile Quarkus applications down to native and get that super fast, super small footprint, super fast startup times that help us in those serverless use cases. So let's do this. Let me jump into, well, let me cover one more thing, just because you'll see that demonstrated here when we walk through the demos here. Going back to the workflow that I talked about, redeploying, automatic redeploying of the applications after there's been some, source code change or configuration change. So what this helps us do is go from what is a typical workflow. You write code, you compile it, you deploy, you refresh your browser, you repeat that process. It goes, over and over again. That process is followed. With Quarkus, you write your code, you refresh the browser, and you repeat. So you see the comic here on the right-hand side of the slide. That's something that, as developers, we like to joke about, right? The compile times, but it's really no joke. They actually cause a major drain on productivity as you have to do that, compile, redeploy, refresh your browser, repeat. So instead of taking, minutes, if not more, to recompile your code, Quarkus aims to solve this with the live coding feature. So when you're running in development mode, the workflow is pretty simple. So let's actually jump over to show you some of them. And so let's do this. What I'll do is show you how to get an application started, and then that way we can jump into the code without too much effort. So there's two ways for you to get started with. It's weird. For whatever reason, I can't click on my other tab here. Okay, well, that's kind of odd. Let me see if I come out of here one more time. Okay, well, anyway, there's two ways to approach getting started with Quarkus. You go to quarkus.io, and there's a button on the right-hand side of the screen that says Start Coding. And if you click on that, it'll take you to a site called code.quarkus.io. And on that page, you can actually bootstrap the start of your application, meaning that you could choose the name of your application, the domain, whether you're using Maven or Gradle, for example, how you want to name, version name your application. So there's some attributes that that you can fill in to help with your application. And then you can choose whatever frameworks that are required for your application. So let's say you're working with a database application, or you're working with Hibernate, whatever the case may be. There's hundreds of extensions, and I'll show you this here, hopefully here in a moment. Hundreds of extensions that are provided that allow you, that you can actually incorporate just by clicking on a checkbox, and those frameworks will be added to your application file. And then that's all converted to a zip file that you can download, or you can associate with your Git repository. So it's really easy to get started and bootstrapped with Quarkus. You can go to quarkus.io, or you can achieve the same thing via the command line. And I'm going to see if I can't. Bear with me here just one moment.
You might have to stop sharing and then share the new tab again. Click to the new tab and start sharing again. That might work.
Okay, it's no big deal. We can get past it. So what I've done, yeah, because it won't let me. I'm going to stop sharing here for a moment. Let's try it again. Because I want to show you my VS Code environment. Okay, looks like it's working now. Okay, phew. So what I've done is I've created an application using that flow that I just mentioned. I went to code.quarkus.io. I chose just a basic file, a basic framework for my Quarkus application. I downloaded the zip file. I unzipped that file, and then I opened up VS Code. And you can see that here on the left-hand side, some things have been generated for me for the project, right? There's source code that's been generated, a real basic application that comes by default, just a simple hello application with a hello endpoint. You'll notice there's a bunch of other resources, and we'll cover some of these as we go along. What I do want to point out is, in addition to a basic application that's generated for us, Quarkus also creates Docker files for us, and this will be important when we start creating our images here a little bit later on in the demonstration. So just by creating and choosing the frameworks at code.quarkus.io, the process for creating the bootstrap for this application includes those Docker files for creating an image that would run either in JVM mode, right, the hotspot mode, or if I wanted to compile a native image, it provides a Docker file for that too. So that's generated for us automatically. So what I've got here is, again, the basic application that I've created. And I can just do, as I mentioned a little bit earlier, the live coding feature, I can just type in Quarkus compile, I'm sorry, Maven compile, Quarkus dev. So that's going to compile our really simple application, start the application in dev mode. And I'll show you what that means here in a moment, and some of the productivity that you get with dev mode. So notice here that we're in dev mode. That's been activated, and we're in live coding is activated. You can see that here at the bottom. And notice that we've got that our application is listening on port 8080, and it started up in 2.13 seconds, pretty quick. So let me bring up a browser here within my VS Code environment. And if I go to that endpoint, Well, let me show you. By default, it creates this default application. So if you create that basic application, click on the 8080 port of your local host, you'll get this a basic application. I can also go to the endpoint, which is created here in the application, and it simply just provides a hello statement. So if we were to make a change in our application and refresh the browser, notice that I didn't have to make that I didn't have to go out and recompile the application. Going back to what I said a little bit earlier, there was a change made to the source code. So Quarkus is intelligent enough to scan the application, scan for changes, and make the change. Notice here on my terminal screen at the bottom, it did a hot replace. So it replaced the original application that just said hello with the new application that says hello Moser IT. Right, so if I change it back and refresh the browser, those changes are reflected and the recompilation took place. Right, so pretty cool. Again, this really helps with developer joy and the whole experience with developing applications. I also mentioned a little bit earlier that not only that if source files change, like the Java file just changed, but if I make any kind of changes to the, oops, let me get rid of this here for a moment. If I make any changes to the configuration file, so let's say I want to use port, I don't know, 9090 instead for my application instead of port 8080. So I'm just gonna add that to my configuration file. Let me bring the browser back up. And let me go to localhost 9090. Oh, I had to refresh it. Come on. Let's go to hello. Okay, well, it's not cooperating with me here in a moment. Well, what should have happened is because I changed support to 9090, my Quarkus application should have recognized that there was a change in the application.properties file and changed the port to 9090. Let me do this. Let me just restart the application here. See if that solves my problem. Live demos. Okay, so you can see now that's listening on port 9090. And if I hit refresh the browser, it says hello. Okay. So that just illustrates that we can make changes in either our source files, in our .java file, or in our configuration file. In this case, we just changed the port of our application to 9090. And any of those changes are instantly recognized by Quarkus, and it's intelligent to know that we can start up on the port and now use 9090 as our port. So let me go back here to the slides if I can. Okay, good. Okay, so I mentioned a little bit earlier about the configuration files and how that plays into Quarkus understanding whether you're in dev, production, or for example, test mode. So that configuration file that I just changed the HTTP port, I can also designate different attributes or configuration profiles based on where I am in the development process. So for example, if I have a data source that I want to use just in my test environment or my dev environment, I can actually, using a syntax with %prod or %dev or %test, I can actually create different profiles that will be referenced when I recompile my Quarkus application. So you can see in this example, for test, I'm using different drivers. For JDBC, I'm using the H2 driver. But when I'm in production, I want to use a Postgres. So when I run my application in dev mode, of course, I'm going to be using the H2 driver. But when I run in production mode, when I compile it, when I package the application, and we'll go through a demonstration here in a moment, when I package the application for production, then of course, the configuration file, the prod, the %prod will be referenced in the configuration file. So we can have multiple different profiles with multiple different configuration values in the application.properties files, and you can select between them based on what mode you're in. So we didn't have to specify a specific profile when we're running our application. Quarkus scans the application's .properties file and looks for that particular profile and executes using those configuration profiles. So pretty cool. Again, this can house, as you can see here, we're using different drivers in the example, but it could be different passwords, usernames, passwords for accessing databases, etc. So you can break down everything into profiles based on where you are in the development process. Okay, let's get to benefit number 2, which is Supersonic Subatomic Java. So here I've got a graph, and this is frankly just a really basic REST application. But if you create this application in a traditional cloud native stack, the size of that application would be around 136 meg. And you can see using Quarkus running on hotspot right in the JDK mode, we've cut that in half to about 73 meg. And then if we take it a step further and compile it in native mode, well, then we're down to about 1/10 of the size of resident set size, right, the RSS size. So you can see we can get, based on our use case and how we're going to deploy the application, we can get into some really small footprints for our traditional applications. Now, if we add a little bit more of an advanced application, maybe a CRUD application on top of it, you can see again the metrics. I won't walk through it, but you can see we're still at about 1/10 of the size if we get the native compilation. And certainly we've reduced it significantly just running on JDK. Startup times, obviously, when we have smaller footprints, we can translate that into faster startup times. So those 2 applications that I just covered as far as RSS size, memory size, you can see the startup times are pretty impressive. Traditional stack, 4.5 seconds, somewhere around there. Quarkus under 1 second running on the JVM. And then natively compiled, we're way down. And the same holds true for the CRUD applications too. So now you can see where Quarkus applications can work and run in a serverless environment because we've got that fast startup time that's required for serverless. So before I get on to the next, let's walk through some other demonstrations here. Okay, let me stop this application. So what we're going to do next is I'm actually going to package the application, and then we'll walk through building out some images using those Docker files that you saw a little bit earlier that are auto-generated for us. So we're going to package the application. I'll show you the application running. Then we're going to compile it into a native image. And then we'll run both those applications so that you can see the size that we kind of reflected in these 2 previous slides, and then the startup times. So you'll be able to see what startup times, how that's reflected in the startup times too. So we'll begin by just packaging the application. So we'll just do a Maven package to package the application. And it'll take a second, but it'll create a jar file for us. So it's compiling, it's running through the tests. One thing I should mention is that the tests are, unit tests are also auto-generated for you. So by default, there's unit tests that are created with that bootstrap that I mentioned a little bit earlier. So there's no need for you to write, at least initially, some tests. Of course, as you get more advanced applications, you can write your own tests, but there's some basic ones that are included already. Okay, so we've created a jar file, so I can just run this jar file. Oops, jar runs jar. Let's see, it's in the target directory. And that'll be, what do we call it, Quarkus, Moser IT. Runner.jar. So we can just run that package application, that jar file that was created. Notice it started up in 2.8 seconds. And if I refresh my browser here, you can see that hello application is still running. So let me stop this. And now we'll go ahead and actually run a native compilation. This takes a couple of minutes, so I'm going to start it, and then we'll talk about a few things. In fact, I'm just going to paste this here, just so you have to watch me fumbling through typing. One thing that I will point out: so to create a native image, you just pass the -p native flag to the package, and notice that I've defined here a native container runtime. Now I'm using Podman. Certainly Docker is an option here. I'm sure most of you are probably running Docker in your environment, but if you haven't heard of Podman, it's just an alternate, there's an alternate tool set that includes Podman and Builder, you see here in a moment, that allows you to manage your container and Kubernetes environment. Anyway, when I package my application, I just want the runtime to be optimized for Podman. So that's all you're seeing here with that designation. So again, this is going to take a couple minutes to compile into native mode. And then we'll actually run that application. You can see the startup time for that application too. Do we have any questions while this is compiling? I don't see. No? Okay. So maybe what I'll do here as well, this is compiling. We'll come back here because it'll take a minute or two to get back. Let's talk about benefit number 3 while that's compiling. And that's the fact that we can actually unify two environments that typically you had to choose one or the other when you're developing applications, and that's imperative and reactive. So we can combine both in the same application. Of course, it's, yeah, great. Of course, it depends on the technology and whatever fits your use case. You don't necessarily have to, but the fact is that based on whether you have a reactive system, maybe you're creating an event-driven application, Quarkus is powerful enough to be able to combine the technologies into one or into the same application, I should say. Best of breed frameworks. So I mentioned earlier that if you're developing Java applications, you've probably used a framework, one of these frameworks at least, and there are literally hundreds of them. In fact, now that I think I can, well, I can't go back to the tab. Anyway, there are hundreds of actual frameworks that you can include in your applications. This is just a snapshot of some of those frameworks that you can include, some of the more popular ones, of course. If you're writing Spring applications today, we actually have a Spring compatibility mode for Quarkus, so that's supported. If you're writing Camel applications, there are dozens and dozens of integration frameworks based on Camel. Of course, if you're doing any kind of monitoring, Prometheus is supported if you're writing event-driven applications, Kafka-based applications. All of those frameworks are supported within Quarkus right out of the box. So let's talk a little bit about how Quarkus works. Let me check to see how my compilation is going here. Oops, that's not what I wanted. Okay, it's still working. We'll continue on while that's happening. So let's talk about how we get those fast startup times in those smaller footprints. And essentially we do that by moving a lot of the work that is normally done at startup time to build time. So you can see on the left-hand side of the screen what a framework does at startup time. And there's a lot of things that happen. There's parsing and configuration files, there's class scanning, all those things that go into preparing reflection, that go into an application starting up. What we've done is we've moved as much as possible to the build phase. And what this helps us do is obviously minimize runtime dependencies, right? So we can eliminate a lot of the dead code that we don't normally need in an application. We can introduce some really clear contracts for metadata, and we can introduce some levels of optimization that you normally don't see, or at least are a little bit more difficult to achieve in a normal application, normal startup of an application. So the benefit to this is that the benefit of moving it to build time is that we do the work once, right? We don't have to do it each time we start up the application. All those bootstrap classes that we don't need when an application is running are no longer loaded. So that means we have less time to start, and obviously we're using less memory. And there's less or no reflection or dynamic proxy that's required. So we move, again, by moving a lot of the traditional startup time optimizations to build time, we can achieve all these benefits. Let's see if okay, we're almost done building our native mode application. And things will move a little bit quicker after this. As you might imagine, it takes some time to build natively an application. And I'll describe, by the way, what you need to actually build a native application and some of the prerequisites that you'll need. So, okay, so there it is, it's done. It's finished building my, my package. So I can run this, Quarkus. So my natively compiled application started up in 31.031. So a lot faster than you saw with the traditional jar file startup. Okay. So now what I'm going to do is I'm actually going to build an image based on those Docker files that you saw a little bit earlier. Again, I'm going to be using Builda. You can use Docker. So you can see this. Well, here, let me do this. Let me clear this out so you can. I'll paste this so you can see the command line a little bit clearer. So notice I'm using Builda. I can actually reference that Docker file. So if you're using Docker, you'd just be, a Docker, Docker -f, and you'd point to this dockerfile.jvm file. So I'm just using Builda, just different tool set, but the result will be the same in the end. And this is the JVM version. So this is the JVM image that I'm building, a container image that I'm going to be building out. So it's going to go out and build this image. Shouldn't take too long because I think most of the packages have been downloaded already, but it looks like it is going out and grabbing some. So it's going to build this JVM version of that really simple application that we built, that hello application. And then after that, we're going to run this this specific version, this specific image. I'll show you the size of it here also too. And we'll do a comparison between this one and the native image that will run after it. So this will just take a minute to build out. Hopefully. I guess I should have just used the one I built already so that we didn't have to go through this, but I'll do that on the next one. Okay, it's almost done here building. It's just copying over some deployment libraries. And it's creating the Quarkus dash Moser IT JVM version of the image. I think my system's probably being text because we're doing video. Okay, there we go. Okay, so we've got the image built out, and then I can just simply run this this container again. Instead of Docker, I'm going to be using Podman. Again, it just depends on what you use in your environment and what tools you want to use in your environment. So I'm just going to be running that JVM version of the application. So you can see it started up in 3 seconds. It's running on port 9090. So if I refresh this, you'll see the hello application running. What I do want to show you is if I do a podman PS, and this could be a Docker PS command, right? I'll get the container image ID here, and we'll just do a podman stats. Whoops. And we'll plug in that container ID. So I want you to notice that it's using about 170 meg in memory, and the CPU is obviously not being taxed at all. Okay, let's go back to our application. So let's this time let's build the image out using the native compiled. So we're going to run basically that same build a command. This time we're going to be referencing the dockerfile.native that you saw a little bit earlier, and this should happen. This should actually not take long at all, and you can see it was a lot faster. In fact, let's do a really quick comparison. So if I do a podman images, and I do script for Moser. So you can see here's the two images we built. The JVM version is about 513 meg in size. The natively compiled version is 136 meg. So quite a contrast in size of the images. So let's run that natively compiled one that we just built. So you can see it started up. So this is a container that's starting up, mind you, in 0.033, and it's running. Refresh the browser, and you can see that in fact it is running. And then we'll come back over here, and we'll just do the same thing. We'll get this image, and we'll plug in that image. And you can see this time we're at, so the previous version that we ran, the JVM version, was about 170 meg. This one is around 35 meg. And of course, the CPU is just hanging out somewhere around 0. So we can achieve incredibly small footprints, especially with a native compiled application. And of course, that translates into incredibly fast startup times, as you saw with the especially with the natively compiled application. Okay, so let's go back and explain a little bit more about how this works and how we can actually achieve that. Okay, so what you saw happen during that compilation step that we kind of moved away for a while is a couple things that are happening, right? You're compiling your application, you're curating or provisioning the frameworks that you included in your application. Then there's some wiring and assembly that goes on. And then in our two examples, you saw that we built a runnable hotspot image, right? Just the JVM image. And then we also built the native image. So you can see that depending on what image we build, there are different steps, obviously, that take place. So we get this runnable Java app when we do the native compilation, and we end up with the native executable and an image. Now, what we use to create that native image is something called a growl, the growl VM. So if you're not familiar with growl, it's a polyglot cross-language JIT that supports many different languages, some dynamic right out of the box. It can do cross-language interop. It supports a native binary compilation so that you can get that fast boot time. So this is a project that was born out of Oracle. There's both a community version and, of course, an enterprise version that's supported through Oracle. And if we take a little deeper look into what the growl VM looks like, notice there's different components that make up the growl VM, including, you can see support for some dynamic languages like Ruby and Python, but there's also support for other polyglot languages like C. Truffle allows us to be able to support those languages, and Sulong for others. Notice that I've highlighted the red, some components in red, specifically the JVM, the compiler, and the substrate VM. With Quarkus, those are the only three components that we use. So we don't use Truffle, we don't use the other components of growl VM. We just use the JVM, the growl compiler, and the substrate VM. And there's some reasons for that. We've actually started or created a project from the upstream growl VM project called Mandrill. And so consider this a downstream of the growl VM that allows us to achieve a few different things. Number one, it allows us to bundle OpenJDK 11 on top, so that's supported in a lot of different platforms, Linux platforms, and other OpenJDK distributions. It's not a fork, so understand it's not a fork of the project. It's just simply a way for us to be able to manage it a little bit better and align it with some of the things that are important to you as developers, especially support for OpenJDK, upstream, etc. So, and it also offers us a way to better support customers that might be using native compilation. So Mandrill is what we're going to be using. It's a subset of the growl VM. It's not a fork. It's part of the growl VM project itself. But I just wanted you to understand that we're kind of working on a downstream project that will help with native compilation in a supported manner, right? So you can get support from Red Hat on it. Now, I've talked about a lot of cool things, fast startup time, small footprints. Of course, there's always a dark side, right? It's not always sunshine. So there are some things that as a Java developer that you're used to that aren't supported. And that's because we frankly had to make a trade-off to be able to support those to achieve those fast startup times and smaller footprints. So you'll see things like dynamic class loading, invoke dynamic, some things that are pretty important Java developers aren't supported. But there is a trade-off, right? In order for us to get that fast startup time to support maybe some use cases that traditionally Java didn't support, there's some things that we have to remove from a traditional Java environment. Now that said, reflection is still possible. You just have to define it manually at the onset. Same is true with dynamic proxy. So, I mean, there's still some things that you can do. It's just that it's more of a manual process than you might be used to in a traditional Java development environment. So I just want to highlight that. Of course, there's some really great benefits to this environment. Number one, native compilation. 100% of the ecosystem is supported with native compilation. So all those frameworks that I talked about a little bit earlier, whether you're using Camel or Prometheus or Spring, whatever the case may be, all those frameworks are supported, and we can get native compilation, so you can realize some of those speeds that we talked about in startup times. Of course, we're able to minimize dependencies. We talked a lot about that already, and of course, dead code elimination. That's a super benefit. So how do you do native compilation? How do you take advantage of Mandrill? You'll need to download, obviously, you need some sort of Java framework in place. Java 11 is now what's supported with GraalVM. So if you're not on Java 11, you need to be moving in that direction. You need, of course, a typical development environment. You need to set some variables, and then you need to install, using a Graal tool called GU, you need to install the native image, that substrate component of the GraalVM that I highlighted in the block diagram. And that'll allow you to create the native image. And then, of course, you need some sort of runtime and container runtime environment. And that could be Docker or Podman, as I illustrated a little bit earlier. And that's the commands you use to actually run it. So building a native executable looks something like this. You take your application, you produce that executable, it's containerized, and then you have that image. And we walked through that demonstration a little bit earlier. And then the end results is some of the things that we just talked about. Again, I just want to highlight the trade-offs, right? That lack of kind of build once, run anywhere that you're used to as a, well, quote, I'll put that in quotes, as a Java developer. The trade-off is some of the other things that we've already talked about, the hot reload capabilities compared to kind of a lower, smaller footprint and startup time. So it fits the use cases that traditionally wouldn't fit. When would you want to use it? When would you want to use the VM version versus the natively compiled version? Here's some use cases for each one of those. But it's really, it's dependent on your use cases and how you want to approach the development moving forward with some of your applications. Getting started is really easy. Again, you can just go to quarkus.io, get started using code.quarkus.io. That really helps you bootstrap quickly. Obviously, I use VS Code. There's an extension for VS Code that plugs right in. Same is true for Eclipse. If you're using Eclipse, there's extensions for that. Maven, if you're using Maven, Gradle is in tech preview right now. So if you're using Gradle, that environment, and then optionally, if you want to compile to native, you would need either Graal or Mandrill. There's just a screenshot of the VS Code extension that plugs into VS Code. I use that. Here's a screenshot of the code.quarkus.io that I couldn't bring up on the browser. Again, you can configure your application in the top left of the image. You can define your group, the name, the artifact, the name of your application, what build tools you're using, the package name, etc. And then you can choose the extensions that you want to choose, and then you simply click on generate your application, and that's where it'll generate the zip file for you, or you can associate it, provision out to your Git repository. So this is all great. What if I want to move to Quarkus and I need support for it? Since that's important to a lot of organizations. Well, we provide support for Quarkus via runtimes. So you can talk to Moser about that, and how you can take advantage of runtimes and some of the other frameworks that are provided as part of runtimes. So if you need support, you want to get it into production. By the way, we do have customers that are using Quarkus in production today. You can get support through us. So you've got existing applications. So for example, Spring applications, and you want to start exploring Quarkus. Are there any tools in place? Well, there are. So we've got a free tool that you can download called Migration Toolkit for Applications. And it's essentially, it's a combination of different open source tools that allow you to analyze, and it generates a really nice report of the effort it would take you to migrate an application, in this case from Spring to Quarkus, or it could be from WebLogic to JBoss EAP, or it can be Oracle JDK to OpenJDK. There's different rule sets that are defined within the tool. And what we've done is created some initial rules for moving Spring Boot applications to Quarkus. So you can download this tool. There's just a real minimal rule set today, but in November, when 5.1 of the migration toolkit is released, you'll see a more expanded or robust rule set for moving your applications over. So in summary, why Quarkus? I think we demonstrated that it's ready for containers. Right? We can get really small footprint size. We can get fast startup times. Certainly, as a developer, you can be more productive. Zero configuration and live reload is just one example of that. You can combine different frameworks and models for developing your applications. And certainly, we've created a way to use optimized versions of Java applications for all different kinds of use cases, whether it be microservices or serverless. You'll have access to these slides, but there's lots of different resources that are available for you, including links to the Quarkus forum where you can get a lot of questions answered, a nice cheat sheet. There's a roadmap, so if you're curious about what's happening down the road with Quarkus, and then of course there's a really great YouTube channel where they hold weekly sessions on technical aspects of Quarkus. To get started, again, there's lots of different tutorials out there that can help you jumpstart your learning process for Quarkus. So I encourage you to do that. We have a full day workshop that if you want to do that, you can work together with us and Moser, and we can get that scheduled out if you want to really dive deep into Quarkus. So I'm sorry, I only left a couple minutes for questions, but are there any questions?
And you can type your questions into the chat pod there if you have anything for Scott. We will be sending out a follow-up email to everybody who registered with links to the recording and some other info, on some other upcoming webinars we have with Red Hat. And we will be, I know there is a DoorDash gift card for coming today. That will come under a separate email from DoorDash. If you don't see it in the next couple of days, just look in your junk email for that. Sometimes it goes there. So be looking for that email. If you have any questions for Scott, type those in the chat pod and we'll stay around for a minute for that. Other than that, thank you very much for coming today. And thank you, Scott, for the great presentation.
Yeah, thanks, Melinda. I appreciate it. There's my email. Feel free, again, to send me an email if maybe questions come up as you start to digest some of the things that we went through rather quickly today. Feel free to send me an email. I'll be happy to reply and answer your questions.
And so I will stay on the webinar for a few minutes.
Hopefully you kind of got re-energized if you've been a Java developer and you're thinking, I'm looking for something a little different, like I was. Don't get me wrong, not that innovation hasn't been continuing with Java, but I think this is really something that is really intriguing, and it's really captivated me.
It's 1 o'clock.
All right, I'll stay on here for a few minutes. If anybody sticks around and types in any questions, we'll try to address those in the follow-up email. So I'll keep this open for a few minutes, but thank you very much for attending.
Thanks, everyone.